Hi Vikings, Mr. Mac here, wrapping up chapter 9 for IM2 here in week 5 of your distance learning. I'd like to do a few problems here that I feel like might present a little bit of an issue. But y equals x squared plus 5x, you're going to complete the square, but there's no c value there. So what we're going to do is we're going to take b divided by 2 and we're going to square it, if you remember when you complete the square. So b divided by 2, and then we're going to square it. So that's 5 divided by 2, which I'm just going to leave it as a fraction. It's 5 halves, and when I square that, I get 25 on top and 4 on the bottom. So that's x squared plus 5x plus 25 fourths. And then when I add the 25 fourths to this side, I got to do it to the other side too. All right, then that's going to make a nice perfect square, and whatever b divided by 2 is what goes here. So b was 5 divided by 2, so that's just 5 halves. And then the last step is to subtract 25 fourths from both sides, so I can get y by itself, and then it'll be in graphing format. So my vertex is just going to be the hk value. So if h is 5 halves, then remember there's supposed to be minus 5 halves, so that's a negative 5 halves. The h value is the opposite of what's there. And then the k value is whatever is there. So there's that one. All right, there's your vertex. Okay, just a reminder, let's see here. When we're shifting stuff left and right, the a value represents your stretch factor. So if that number is bigger than 1, it's going to cause your parabola to grow faster, so it'll make it skinnier. If that a value is less than 1, it's going to not grow as fast, so it'll be wider. And then if it's a positive value, it'll open up. If it's a negative value, it's going to open down. And the same is going to hold true for if it's a parabola. All right. The hk value, like I said before, it's a minus h, so it's the opposite of what's ever there is going to be your first value. That h value controls whether it goes left or right. So if you have x minus 5, it's going to move it to the right, positive 5. If it's x plus 5, it's going to move it to the left. So it's the opposite because of that negative sign. And then k is just whatever it is, and that controls up and down. So if it's plus 5, it would move it up 5. If it's minus 5, it would move it down 5. So keep that in mind for number 2. Here for number 3, just remember to use an XY table to plug in some points so you can sketch your graph more accurately. And remember, locator point is the same as vertex. Here for number 4, I'm going to do B with you guys. And we'll go from there. So 3x plus 9 is greater than 2 times 4x minus 3. So I'm just going to solve this as if this inequality was an equal sign. So 3x plus 9 is equal to 8x minus 6, and I'm going to find the locator point. All right, so I'll subtract 8x from both sides, and I'll be left with minus 5x plus 9 is equal to negative 6. And then from here, I'm going to subtract 9 from both sides. So minus 5x is equal to negative 15. And then I'll divide both sides by negative 5. So x equals 3. That's my boundary point. And then I'll need to make a graph and just put in 0 as a reference point and 3. And then I'm going to circle above. I'll put my graph above, an open circle above, and then I'm going to go back and check my original inequality to see if I need to fill my circle in. Since there's no line underneath, it's not greater than or equal to, it's just greater than, I'm going to leave it open. If it had a line underneath for greater than or equal to, then I would fill it in. Now I just need to know whether I'm going to go to the left or right. So I'm going to always test 0. So I'll plug 0 into this original inequality. So 3 times 0 is 0, and then I'd have 9 on the left is greater than 4 times 0, so that's minus 3, and then 2 times minus 3 is negative 6. Is 9 greater than negative 6? You're going to ask yourself that, and that is true. Yes, it is true. Oops. Yes, it's true. 9 is greater than negative 6, so when I tested 0, I got a true statement, so everything goes that way. And then your last step is to write what you see in terms of x. So this is x is everything that is less than 3. And there's your answer. Now, if we go back here, instead of changing this to an equal sign, if you left the sign, you can do these problems, and then anytime you divide, so right here we divided by -5. If you divide or multiply to solve for x at any point, if that sign is negative, then what you need to do is you need to switch the sign's direction. So that's why this ends up being x is less than 3. And here's the proof when we tested 0. Okay, so just remember, if you want to solve this without doing the test point, you need to use or change the sign anytime you divide or multiply to solve for x by a negative number. You're going to change the sign. Ooh, dropped you. Well, that'll be fun. Okay, so what else do I want to go over? I want to do, so these are a little different. They're inequalities, but they're quadratic inequalities. So you're going to have to factor one side. So I'm going to do b with you. We've got b, or 6 rather, is less than or equal to x squared minus 6x minus 10. So the first thing I'm going to do is I'm going to set everything equal to 0. So I'll subtract 6 from both sides. So I'll get 0 is less than or equal to x squared minus 6x minus 16. And so now I'll use a zero product property and factor this side. So my first times first are going to be x and x. And then since I'm getting a negative answer for my last, remember FOIL, my first times my first gives me that, and then my last needs to be 16. So in order to get a negative, I'm going to have a different or opposite signs. And then factors of 16 to get me negative. I'll put the big one here, 8 here, and a 2 there. So my last terms are -8 times 2, which gives me -16. And then my outers give me plus 2x when I multiply them together. And my inners gives me -8x, so that gives me the -6x. So zero product property, I'll set those equal to 0, and I'll get x is equal to 8, and x is equal to -2. Okay, so it's just the opposite of what's there. And those represent my boundary points. So I'm just going to do a makeshift graph here and always put 0 down. Here's -2, here's a 0, and then 8 would be somewhere a little further over there. And I'm going to go ahead and graph my boundary points above. I'm going to go back to my original inequality and see whether or not I need to fill them in. So since this is less than or equal to, I'm going to fill these guys in. Now I need to know whether to draw the line in between the dots or to go opposite directions. And so I'm always just going to test 0 to see what happens. So I have 6 is less than or equal to, if I plug 0 in, I'm going to get -10 on the right. So is 6 less than or equal to -10? The answer would be no. So since I tested 0, which is in between, and I got a no, I'm going to put my graph going the other direction. And then the last thing to do is to write your inequality statement. So x is everything that is greater than or equal to 8. And then on this side, your sign's always going to be the same direction as the first one. And then your other boundary point. So this reads x is greater than or equal to 8, but then if I go this direction, x is also everything that is less than or equal to -2. And then that would be your final statement. All right. Let's see here. A couple other things you need to remember. The formula for the area of a circle. The area of a circle is equal to pi r squared. And then the circumference of a circle is pi times the diameter. Remember, the diameter is exactly twice the radius. And sometimes they're going to give you the area, and you got to find the radius, or they'll ask you the diameter. Other times they're going to give you the diameter, and you got to find the area. So there's just start with the generic formula and then figure out the thing that's missing. You're also going to need to know your trig functions. So SOHCAHTOA. Sine is equal to the opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You'll need that for number 9, or you could also use the Pythagorean theorem once you get 2 sides, because it's only good for right triangles, remember. And then number 10 here, we're dealing with a regular polygon, so you'll need to remember that an exterior angle is 360 divided by the number of sides. And then exterior angles and interior angles are supplements. So it's another way you can find, remember that they both add up to 180 degrees. Or if you want to form the formula for interior angle, it's going to be 180 times n minus 2 divided by n. And then if you want to know all of the interior angles, then you just don't divide by n. That's all of them. All right, hopefully that'll help you with your assignment this week. If you have any questions, email me and we can do a Zoom session and get you straightened away.